Good afternoon, very good morning, students. So today our topic is power factor and its importance. So my name is Gurinder Pal Singh. I am senior lecturer at Government Polytechnic Amritsar. I have my contact number 8968653344. So before we are going to study what is the power factor and what are the importance of power factor, so I want to share some information with you that I have an experience of 25 to 30 years of teaching. So I, after so many years, you can say that after teaching 3 to 5 years and 25 years, so I come to know what the power factor actually is. So for you who are studying in third semester in electrical engineering, so it is difficult to understand what is the power factor basically. So what is the inside story of the power factor? So I request all of you to hear this lecture with top priority. So first of all, we will see what power factor is. Power factor ਨੂੰ ਸਮਝਣ ਲੱਗਿਆਂ ਸਾਨੂੰ ਇਹ ਜ਼ਰੂਰ ਸਮਝਣਾ ਹੋਵੇਗਾ ਕਿ ਵੀ ਹੈਵ ਡਿਫਰੈਂਟ ਟਾਈਪ ਆਫ ਲੋਡਸ। ਜਿਸ ਤਰ੍ਹਾਂ ਤੁਸੀਂ ਆਪਣੇ ਥਰਡ ਸਮੈਸਟਰ ਇਲੈਕਟ੍ਰੀਕਲ ਦੇ ਸਿਲੇਬਸ 'ਚ ਪਹਿਲਾਂ ਹੀ ਪੜ੍ਹਿਆ ਹੋਏਗਾ, we have 3 different type of loads. One is known as resistive load, and other is known as inductive load, and third is known as capacitive load. So in resistance, current and voltage both are in same phase. When the load is inductive, the current I lags behind the voltage by 90 degree for a pure inductive load, and when the load is capacitive, the current leads the applied voltage by 90 degree. The condition is the load is exactly ideally it is capacitive load. So we must know what the AC current is. AC current किस तरह flow होंदी है, AC current दी instantaneous value की होंदी है, instantaneous value तो बाद इहदी maximum value की होंदी है. Then you must have studied about the RMS value of AC voltage and current. So when you know the quality of AC, when you know the properties of AC current and voltage, then you are able to understand what the power factor is. So there are 2-3 definitions of power factor. So ਸਿਰਫ definitions ਦੇ ਪੜ੍ਹਨ ਦੇ ਨਾਲ ਅਸੀਂ ਕਿਸੇ ਚੀਜ਼ ਨੂੰ ਐਜ਼ ਏ ਲੇਮੈਨ ਲੈਂਗੁਏਜ ਦੇ ਵਿੱਚ ਨਹੀਂ ਸਮਝ ਸਕਦੇ. ਸੋ ਸਾਨੂੰ ਉਸ ਚੀਜ਼ ਬਾਰੇ ਇਨਸਾਈਡ ਸਟੋਰੀ ਜ਼ਰੂਰ ਪਤਾ ਹੋਣੀ ਚਾਹੀਦੀ ਆ. So first of all, we can say that the power factor is defined as the cosine of an angle between voltage and current. So you can see over here a vector of a voltage, and again you can see the vector of a current. So both these vectors are placed between each other by an angle phi, or you can say the current is lagging behind the voltage by an angle phi, or you can say the voltage is leading the current by an angle phi. But in our electrical system, ਜੋ ਅਸੀਂ ਇਲੈਕਟ੍ਰੀਕਲ ਦੇ ਵਿੱਚ ਪੜ੍ਹਦੇ ਹਾਂ, ਤਕਰੀਬਨ ਅਸੀਂ ਵੋਲਟੇਜ ਨੂੰ ਇੱਕ ਰੈਫਰੈਂਸ ਵੈਕਟਰ ਮੰਨਦੇ ਹਾਂ ਅਤੇ ਕਰੰਟ ਨੂੰ ਉਸ ਤੋਂ ਲੀਡਿੰਗ ਜਾਂ ਲੈਗਿੰਗ ਦੇ ਫੈਕਟਰ ਦੇ ਨਾਲ ਅਸੀਂ ਉਹਨੂੰ ਕਾਊਂਟ ਕਰਦੇ ਹਾਂ. ਸੋ ਨਾਓ ਵਾਟ ਅਬਾਊਟ ਦ ਇੰਟਰੋਡਕਸ਼ਨ ਆਫ ਪਾਵਰ ਫੈਕਟਰ. The power factor of an AC electrical power system is defined as the ratio of the real power flowing to the load to the apparent power in the circuit, and is a dimensionless number between 0 and 1. You can say, ਤੁਸੀਂ ਕਈ ਵਾਰੀ ਪੜ੍ਹਿਆ ਹੋਏਗਾ ਕਿ ਪਾਵਰ ਫੈਕਟਰ ਦੀ ਵੈਲਿਊ ਇਟ ਮੇ ਬੀ 0, ਇਟ ਮੇ ਬੀ 0.1, 0.2, 0.3, 0.4. ਤੁਸੀਂ ਕਈ ਇਲੈਕਟ੍ਰੀਕਲ ਅਪਲਾਇੰਸਿਸ ਤੁਸੀਂ ਫਲੋਰੀਸੈਂਟ ਟਿਊਬਸ ਹੁੰਦੀਆਂ ਤੁਹਾਡੇ, ਉਹਦੇ ਇੱਕ ਚੋਕ ਜਾਂ ਉਹਨੂੰ ਬਲਾਸਟ ਕਹਿੰਦੇ ਆ, ਇਲੈਕਟ੍ਰੋਨਿਕ ਬਲਾਸਟ ਜਾਂ ਮੈਗਨੈਟਿਕ ਬਲਾਸਟ. ਅਗਰ ਤੁਸੀਂ ਮੈਗਨੈਟਿਕ ਬਲਾਸਟ 'ਤੇ ਦੇਖੋਗੇ ਤਾਂ ਉਹਦੇ 'ਤੇ ਲਿਖਿਆ ਹੋਏਗਾ ਪਾਵਰ ਫੈਕਟਰ 0.2 ਕਈਆਂ 'ਤੇ ਮੈਗਨੈਟਿਕ ਬਲਾਸਟ ਦੇ 0.2 ਹੁੰਦਾ, ਜਿਹੜੇ ਇਲੈਕਟ੍ਰੋਨਿਕ ਚੋਕਸ ਅੱਜ ਕੱਲ੍ਹ ਆਈਆਂ ਉਹਨਾਂ 'ਤੇ ਮੈਗਨੈਟਿਕ ਜਿਹੜਾ ਪਾਵਰ ਫੈਕਟਰ ਕਈ ਵਾਰੀ ਤੁਸੀਂ ਦੇਖੋਗੇ ਲਿਖਿਆ ਹੁੰਦਾ ਉਹਦੀ ਸਪੈਸੀਫਿਕੇਸ਼ਨ ਦੇ ਉੱਤੇ, ਦੈਟ ਇਜ਼ 0.5 0.6 or 0.7. So this power factor varies, cos phi varies from 0 to 1. So real power is the capacity of the circuit for performing work in a particular time. Apparent power is the product of the current and voltage. ਅੱਗੇ ਜਾ ਕੇ ਮੈਂ ਤੁਹਾਨੂੰ ਐਕਸਪਲੇਨ ਕਰਾਂਗਾ what is the real power, what is the apparent power and what is the reactive power of the circuit. Due to energy stored in the load and returned to the source, or due to non-linear load that distorts the wave shape of the current drawn from the source, the apparent power will be greater than the real power. So always apparent power is greater than the real power. So you say over here, you can see ਇਹ ਅੱਗੇ ਜਾ ਕੇ ਵੀ ਸਾਨੂੰ ਸਲਾਈਡ ਇਹ ਕੰਮ ਆਏਗੀ. So we can see the real power, we can see the apparent power which is measured in kVA, kilovolt ampere, as the real power is measured in kilowatt, and the reactive power is measured in kilovolt ampere reactive. So power factor, again the next definition of power factor is the ratio of real power to the apparent power. So in an electric power system, a load with a low power factor draws more current than a load with a high power factor. ਅੱਗੇ ਜਾ ਕੇ ਅਸੀਂ ਇਹ ਪੜਾਂਗੇ ਕਿ why we have to improve the power factor. So ਸਾਨੂੰ ਇਹ ਜ਼ਰੂਰ ਪਤਾ ਹੋਣਾ ਚਾਹੀਦਾ ਕਿ ਜੇ ਸਾਡਾ ਪਾਵਰ ਫੈਕਟਰ ਲੋ ਹੋਏਗਾ ਤੇ ਸਾਡਾ ਲੋਡ ਜ਼ਿਆਦਾ ਕਰੰਟ ਡਰਾ ਕਰੇਗਾ, ਲੋ ਐਂਡ ਲੈਗਿੰਗ ਹੋਏਗਾ, and if our power factor is high and leading, or it is not leading, it is in phase with the voltage, or it is unity, the current drawn by the load is minimum. So the same amount of useful power transform, the higher the currents increases the energy lost in the distribution system and require larger wires and other equipment. Because of the cost of large equipment and wasted energy, electric utilize will usually charge a higher cost to industrial or commercial consumers where there is a low power factor. So this is natural ਕਿ ਅਗਰ ਅਸੀਂ ਲੋ ਐਂਡ ਲੈਗਿੰਗ ਪਾਵਰ ਫੈਕਟਰ 'ਤੇ ਆਪਣੀ ਇੰਡਸਟਰੀ ਨੂੰ, ਆਪਣੇ ਘਰਾਂ ਨੂੰ ਜਾਂ ਆਪਣੇ ਇੰਸਟੀਟਿਊਸ਼ਨਸ ਨੂੰ ਚਲਾਵਾਂਗੇ ਤਾਂ ਜਿਹੜੀ ਯੂਟਿਲਿਟੀਜ਼ ਹੈਗੀਆਂ ਜਿੱਦਾਂ ਪੰਜਾਬ ਸਟੇਟ ਇਲੈਕਟ੍ਰਿਸਿਟੀ ਬੋਰਡ ਜਾਂ ਪਾਵਰ ਕਾਰਪੋਰੇਸ਼ਨ ਹੈਗੀ, ਦੇ ਆਰ ਗੋਇੰਗ ਟੂ ਚਾਰਜ ਹਾਇਰ ਐਟ ਦਾ ਕੋਸਟ ਆਫ ਦਾ ਪਰ ਯੂਨਿਟ. So linear loads with low power factor such as induction motor. So you can say the performance of an induction motor can be corrected with a passive network of capacitors or inductors. Non-linear loads such as rectifier distorts the current drawn from the system. In such cases, active or passive power factor correction may be used to counteract the distortion. So and raise the power factor. So we have, let us say we have certain loads which are running at low and lagging power factor. So to increase the power factor, so we have a very good equipment, capacitors. There are different kind of capacitors, static capacitors and dynamic capacitors. So we can connect these capacitors in parallel with the load to improve our power factor. The devices for correction of the power factor may be at the certain central substations spread out over a distribution system. So distribution system ਦੇ ਵਿੱਚ ਸਾਡੇ ਜਿਹੜੇ substations ਹੁੰਦੇ ਆ ਉਹਨਾਂ ਦੇ ਕੋਲ ਅਸੀਂ ਇਹ capacitor bank ਲਾ ਸਕਦੇ ਹਾਂ, are built into power consuming equipment. So ਜਾਂ ਜਿਹੜੇ power consuming equipment ਆ ਜਾਂ ਬਿਗ ਇੰਡਸਟਰੀਜ਼ ਜਿਹੜੀਆਂ ਹੈਗੀਆਂ ਜਿਹੜੀ ਪਾਵਰ ਬਲਕ ਪਾਵਰ ਕੰਜ਼ਿਊਮ ਕਰਦੀਆਂ ਉਹਨਾਂ ਦੇ ਐਂਡ 'ਤੇ ਅਸੀਂ ਪਾਵਰ ਕਰੈਕਟਿੰਗ ਇਕੁਇਪਮੈਂਟ ਜਿਹੜੇ ਉਹ ਲਾ ਸਕਦੇ. ਸੋ ਫਾਰ ਏ ਡੀਸੀ ਸਰਕਟ ਦਾ ਪਾਵਰ ਐਜ਼ ਯੂ ਨੋ, ਤੁਸੀਂ ਸਭ ਤੋਂ ਪਹਿਲਾਂ ਡੀਸੀ ਸਪਲਾਈ ਪੜ੍ਹੀ ਹੋਏਗੀ. ਇਨ ਡੀਸੀ ਸਪਲਾਈ simple power is equal to voltage multiplied by current, and the relationship also holds for the instantaneous power in AC circuit. However, the average power in an AC circuit expressed in terms of the RMS voltage and current is, so P RMS power P is equal to VI cos phi. So you can see that In DC circuit, power is equal to Vi, but in AC power is equal to Vi cos phi. So where is the phase angle, where you can see the phi is the phase angle between the voltage and current. The additional term is called the power factor. So this is what is the difference between AC and DC power. So in DC power is equal to V into I, but in AC power is equal to V into I into cos phi. So cos phi is a power factor which is multiplied by extra in AC circuit to calculate the power in AC circuit. So so power factor we can also I have already told you that there are three definitions of power factor. One is power factor is cosine of angle between voltage and current. Second definition I have told you that it is the ratio of real power to the apparent power. And we have a third definition also. The power factor is also the ratio of resistance to impedance. So as you know, in case of AC system, uh, when we are going to compare it with the DC system, in DC we have only the resistance which oppose the flow of current, but in AC system we have another two different parameters. We have to calculate inductance and capacitance, and while adding inductance and capacitance with the resistance, it comes out to be impedance of the circuit. So in case of AC circuits, impedance is the opposition to be offered against the flow of current. So from the phasor diagram for AC impedance, you can see in this slide we have resistance along x axis, and we have inductance R capacitance across y axis, and we have impedance. The resultant of resistance and inductance is the value of the impedance. So for the phasor diagram for AC impedance, it can be seen that the power factor is R over Z. So it is the angle. So phi is the angle between Z and R. So phi is the angle between resistance R and impedance Z. So cosine of this angle again is known as power factor. So power factor is R over Z. For a purely resistive AC circuit, R is equal to Z. So as you already know, if you have a pure resistance in the AC circuit, so there is a no inductance, there is a no capacitance, so Z is equal to R. So in this case current R is equal to Z, and the power factor is equal to unity. So it comes to be unity. Or in a waveform, you can say the voltage waveform is overlapping the current waveform, or current waveform is overlapping the voltage waveform, and both the vectors are in the same direction. So next is we have what is true and reactive power. So already we have studied the impedance triangle. So after impedance triangle we have a power triangle. So the power which is actually consumed or utilized in an AC circuit is called true power. So I have already told you the power which is actually consumed in the circuit is known as true power, or it is known as real power. So or we can say it is a active power. It has already been seen that power is consumed only in resistance. So ਅੱਗੇ ਜਾ ਕੇ ਵੀ ਅਸੀਂ ਇਸ ਚੀਜ਼ ਨੂੰ ਐਕਸਪਲੇਨ ਕਰਾਂਗੇ. ਸੋ ਇਨ ਏ ਪਿਓਰਲੀ ਰੈਜ਼ਿਸਟਿਵ ਸਰਕਟ power is only consumed. So in a pure capacitive circuit or in a pure inductive circuit, power consumption is zero. A pure inductive and pure capacitor do not consume any power, since in a half cycle whatsoever power is received from the source by these components, the same is returned to the source. So the power which flows back and forth or reacts upon itself is called reactive power. It does not do any useful work in the circuit. So in a power triangle, so I have told you that there are three different kind of power. One is active power, another is reactive power. So the reactive power, as we have studied over here is called reactive power. It does not do any useful work in the circuit. So the reactive power, the work done by the reactive power is not useful work. So it has been seen that the pure resistive circuit current is in phase with the applied voltage. So I have already told you that in a pure resistive circuit, to understand the power factor, it is very necessary to understand this thing, that in a pure resistive circuit the current is in phase with the applied voltage, whereas in pure inductive and capacitive circuits current is 90 degree out of phase. So in a pure inductive circuit, current lags behind the voltage by 90 degree. In a pure capacitive circuit, the current leads the applied voltage by 90 degree. So it is concluded that the current in phase with the voltage produces true and reactive power, whereas the current 90 degree out of phase with the voltage contributes with reactive power. So over here we can see that the reactive power is produced only in capacitive and inductive circuits. So true power is equal to voltage multiplied by current in phase with voltage. So we can say always, so it holds good only in DC circuits, so where we can say power is equal to V into Y. So again in AC circuit it holds true that true power is equal to voltage multiplied by current, but the condition is when the voltage and current both are in same phase. So the reactive power on other hand is equal to voltage multiplied by current, which is 90 degree out of phase with voltage. So either the current is lagging behind the voltage by 90 degree, or the current is leading the applied voltage by 90 degree. In both the cases reactive power is equal to voltage multiplied by current, and it is the cosine of angle between voltage and current. So this is now power triangle. So you can see here the three different kind of powers. So one is true power, so along x axis. So this true power is measured in watts. So as we have already studied about that true power is equal to Vi into cos phi, and you can see the hypotenuse of the right angle triangle. So the hypotenuse of the right angle triangle shows the apparent power which is measured in volt ampere, and this volt ampere is a small unit, and in bigger unit we can say it is kVA, kilovolt ampere. So along y axis, so we have a reactive power. So this reactive power again this reactive power is Vi sin phi, V multiplied by I multiplied by sin phi. So measured in, so this power is measured in volt ampere reactive. This is a smaller unit, and for bigger unit this power is measured in kVAR, kilovolt ampere reactive. So this is the whole of this triangle is known as impedance power triangle. So again this is a power triangle. So working power which is known as kilowatt, then reactive power kVAR, then apparent power, so it is kVA. So real power or working power which is measured in kilowatt, so reactive power kVR which is measured in kVAR, then apparent power which is calculated in kVA. So then again you can have right angle triangle in which the hypotenuse square is equal to a square plus b square. So similarly apparent power square is equal to real power square plus reactive power square. So if we are going to calculate again if we are going to calculate kVA, so kilowatt square plus kVR square, the under root अगर ਅਸੀਂ ਇਹਨੂੰ कर दईए तो it comes to be a apparent power. Again the current I can be resolved into two rectangular components. So over here you can see we have a vector current we have a vector voltage. So reference ਹਮੇਸ਼ਾ ਅਸੀਂ ਮੈਂ already I have told you ਕਿ ਅਸੀਂ reference electrical ਦੇ ਵਿੱਚ voltage ਨੂੰ ਹੀ ਲੈਂਦੇ ਹਾਂ. So with the reference to voltage in this case the current is leading the applied voltage by an angle phi. So we can resolve the vector I into two components. So one is horizontal and in phase with the voltage, which is known as I cos phi, and other is perpendicular to the voltage, which is known as I sin phi. So the current component I can be resolved into two components. So I can be resolved into two rectangular components, I cos phi in phase with the voltage V, and I sin phi, which is 90 degree out of phase with voltage V. So from this we can measure true power P is equal to multiply I cos phi ਨੂੰ ਅਸੀਂ ਅਗਰ V ਨਾਲ multiply ਕਰ ਦਈਏ. So I and V I cos phi and V both are in same phase, so it comes to be the real power, and the reactive power is VI sin phi, which is perpendicular to the true power, and apparent power again it is hypotenuse, so VI volt ampere or kVA kilovolt ampere. So next is why we are so much talking about power factor, why we tell our customers, why I used to tell my students that you should improve the power factor of your house, or you should improve the power factor of your industry, or you should improve the power factor of your institution by purchasing good quality of electrical equipments, or by connecting a suitable capacitor in parallel with the load. So why it is important? As I have already told you, it is very difficult to understand what the power factor is. So to understand the power factor, again I am going to repeat all these things कि you must know the AC fundamentals of AC, fundamental of a resistance, fundamental of capacitance, fundamental of inductance. So what inductance is, what capacitance is. So we can otherwise we cannot improve the power factor, or otherwise we cannot we do not know how to improve the power factor. So a power factor of 1 or unity power factor. So power factor 1 or unity is the goal of any electrical utility company, since if the power factor is less than 1, they have to supply more current to the user for a given amount of power use. In so doing, they incur more line losses. They also must have large capacity equipment in place than would be otherwise necessary. As a result, an industrial facility will be charged a penalty if its power factor is much different from 1. So in our language, so ਜੇ ਮੈਂ ਤੁਹਾਨੂੰ ਕਹਾਂ ਕਿ ਕੋਈ let us say we have a distribution transformer, ਸਾਡੇ ਕੋਲ 100 kVA ਦਾ distribution transformer ਆ, ਤੇ ਇੱਕ ਇੰਡਸਟਰੀ 50 ਕਿਲੋਵਾਟ ਦੀ ਮੋਟਰ ਨੂੰ 0.5 ਪਾਵਰ ਫੈਕਟਰ ਤੇ ਚਲਾ ਰਹੀ ਆ, ਤੇ ਦੈਨ ਜਿਹੜਾ ਉਹ ਸਾਡਾ ਟਰਾਂਸਫਾਰਮਰ 100 kVA ਦਾ ਟਰਾਂਸਫਾਰਮਰ ਹੈਗਾ ਉਹ ਫੁੱਲੀ ਲੋਡਡ ਹੋ ਜਾਏਗਾ. ਸੋ ਦੈਟ ਵਿਲ ਵਰਕ ਔਨ 100 kVA ਬਿਕਾਜ਼ our 50 kilowatt motor is working at 0.5 power factor lagging. So ਸਿਰਫ ਸਾਡੀ 50 ਕਿਲੋਵਾਟ ਦੀ ਮੋਟਰ ਹੀ 100 kVA ਦੇ ਟਰਾਂਸਫਾਰਮਰ ਨੂੰ ਫੁੱਲੀ ਲੋਡਡ ਕਰ ਦੇਗੀ. ਬਟ ਇਨ ਅਨਦਰ ਕੇਸ ਅਗਰ ਅਸੀਂ ਉੱਥੇ ਦੋ ਮੋਟਰਾਂ ਲਾ ਲਈਏ 50-50 ਕਿਲੋਵਾਟ ਦੀਆਂ, ਅਗਰ ਅਸੀਂ ਉਹ ਦੋਵਾਂ ਮੋਟਰਾਂ ਨੂੰ ਯੂਨਿਟੀ ਪਾਵਰ ਫੈਕਟਰ 'ਤੇ ਚਲਾਈਏ ਤਾਂ ਵੀ ਸਾਡਾ ਜਿਹੜਾ 100 kVA ਦਾ ਟਰਾਂਸਫਾਰਮਰ ਹੈ ਫੁੱਲੀ ਲੋਡਡ ਹੋ ਜਾਏਗਾ. ਸੋ ਦਿਸ ਇਜ਼ ਦਾ ਵੇ how we can get advantages of getting or improving our power factor. So by improving our power factor to unity, we can run 250 kilowatt of motors on 100 kVA transformer. As previously I have told you that the one person is running his 50 kilowatt motor at 0.5 power factor and his 100 kVA transformer is fully loaded. So this is the property of improving the power factor. So industrial facilities tends to have a lagging power factor where the current lags the voltage like an inductor. This is primary. So this is probably the result of having a lot of electric induction motors. The winding of motor acts as inductor as seen by the power supply. Capacitors have the opposite effect and can compensate for the induction motor winding. Some industrial sites will have large banks of capacitors strictly for the purpose of correcting the power factor back towards 1 to save the utility company charges. So ਇਲੈਕਟ੍ਰਿਸਿਟੀ ਬੋਰਡ ਨੇ ਇਹ ਸੋਚਿਆ ਜਾਂ ਪਾਵਰ ਕੰਪਨੀਜ਼ ਨੇ ਇਹ ਸੋਚਿਆ ਕਿਉਂ ਨਾ ਮੈਂ ਸਾਡੀ ਕੰਪਨੀ ਜਿਹੜੇ ਇੰਡਸਟਰੀਜ਼ ਪਾਵਰ ਫੈਕਟਰ ਲੋ ਐਂਡ ਲੈਗਿੰਗ ਨੂੰ ਚਲਾਉਂਦੇ ਉਹਨਾਂ ਨੂੰ ਅਸੀਂ ਪਲੰਟੀ ਕਿਉਂ ਨਾ ਲਾ ਦਈਏ. ਸੋ there are different type of tariff which are available in our industries or ਜਿਹੜੀਆਂ ਯੂਟਿਲਿਟੀਜ਼ ਕੰਪਨੀਆਂ ਜਾਂ ਬਿਜਲੀ ਬੋਰਡ ਜਾਂ ਜੋ ਵੀ ਕੰਪਨੀ ਪਾਵਰ ਸਪਲਾਈ ਕਰਦੀਆਂ ਉਹਨਾਂ ਨੇ ਡਿਫਰੈਂਟ ਟੈਰਿਫ ਬਣਾਏ ਹੋਏ ਆ. ਸੋ ਨਾਓ ਇਨ ਥੀਸ ਡੇਜ਼ one of the tariff is that as you go on lowering your power factor, lowering or lagging, you are going towards lagging power factor, the penalty from the company is going higher and higher. So every industry tries to do his best to improve the power factor by connecting power correcting equipment such as capacitors to improve the power factor to unity. So power again power is equal to Vi cos phi. So what happens, how we can improve or what are the different causes of lowering our power factor. So I is equal to, you can see current is inversely proportional to voltage and power factor. From the above relation it is clear that for a fixed power at constant voltage the current drawn by the circuit increases with the decrease in power factor. You can say as the current is inversely proportional to power factor. So as we go on lowering our power factor, so our current will increase. So what happens if our power factor goes from 1 to 0.8, 0.7, 0.6, 0.5, 0.4, so the current in the circuit will go on increasing. So thus at low power factor AC circuit draw more current from the main and results in the following disadvantage. So what are the different disadvantages are? Number one, so if our power factor is low and lagging, so we required greater conductor size. As you see when the power factor is drawn by the circuit is low and lagging, the current in the circuit go on increasing by the virtue as the current go on increasing, so we required greater conductor size. So at low power factor conductors are to be carry more current for same power, therefore they require larger area of cross section. So so we have to change the conductor of our transmission line or for our distributor or for our house wiring. So we have to spend more money to purchase higher cross sectional area of conductor. Second is poor efficiency. So as we have already seen that as the current go on increasing, so at lower power factor the conductors have to carry large current. Definitely when we I told you first is we have to increase the conductor size as the same conductor has to carry large current. So there is a large current with increases copper losses. So you see that the copper losses are directly proportional to I square R. So R is the resistance of the conductor, and as I increases double, let us say if I increases double, their copper losses increases 4 times and result in poor efficiency. So as the copper losses go on increasing, the efficiency of the line will be decline. The third point is the large voltage drop. Definitely, as we go on increasing the current, the voltage drop, which is the multiplication of current and resistance, so it comes to be voltage drop. So at lower power factor, the conductors have to carry large currents. So if the conductor is carrying large current with increased voltage drop I into R in the system and result in poor regulation. So in